What's up YouTube? Welcome back to Path to Senior JS. Today we're talking about TypeScript. We're going to cover everything from junior level, from arrays, primitive types, how to make your own types, and how it involves functions. And then it's going to lead us into some more senior level code, and we're going to tackle some out-of-the-box TypeScript tools, as well as doing mapped types and how you can really build out your TypeScript architecture to make your code a lot better. So let's get started. All right, guys, so now we're going to recap real quick with junior dev level code for TypeScript. So if you can see here, we're going to start out by just kind of covering real quick how TypeScript works and how to compile the TypeScript into regular JavaScript. So if you just come here and we say normal JavaScript code, console.log, hello TypeScript. If we do another arrow function, such as let compile me, we can see here, let's go down and generate a JavaScript file in the terminal. And before this, I added an npm module called TypeScript globally. So once you install that, you can run the command and actually compile your TypeScript files, which if you look over in the sidebar, or TS, the extension is TS instead of JS. But when we come down here and we actually run the command, which is going to be TSC TypeScript TS, which is our file name, if you look at the sidebar, you'll see a generated JavaScript file right there. And if you look over here, we can see our console.log, and we can also see our arrow function that got compiled into a anonymous function that's attached to a variable, compile me. So that's generally basic level how you generate vanilla JavaScript with the TypeScript code. All right, so moving on, we're going to cover explicit and implicit TypeScript annotations. And we can check that out right here. First, we'll do implicit, which means we're not going to be exactly telling TypeScript what to do. It's just going to guess what it's doing. So if we just make another variable called letFirstTS, and we just assign it to 36, the number 36, what we're going to see is, once we hover over this, we're going to see a TypeScript automatically assigned it to a type of a number, because we assigned it to a number. So now if we went ahead and said like, first TS equals hello, which is a string, now we'll get a error saying, hey, type string is not assignable to type number. All right, and then so that's a way to be implicit, where TypeScript is going to just kind of like see what you're assigning it to, and if we made that a string, it would implicitly assign it to a type string. But now we're going to be more explicit and say, okay, let's do let first TypeScript again, and we're going to specify, hey, we want this to be a number equals 36. And if we do this again, we can see it's kind of doing the same thing. So in other words, if we are going to do it this way and assign it a value, it's kind of redundant to obviously go ahead and also give it a type of number, because it's going to pick up that number the first time. But if we are going to just declare a variable and not give it a value, then it makes total sense to go ahead and give it a type of number, because later on we want only a number value on that variable. So now if we go ahead, we can obviously see like, hey, this is going to be a number. Now if we were to leave this off, it would be implicit as well, but it would be automatically given the value of any, which is pretty much like not using TypeScript at all, and that this variable can be assigned to a number and then a string, and just like regular vanilla JS. And then we go into loosely typed, which is pretty much the same thing I talked about before, where instead of actually giving it a specific type such as number, string, array, we're just going to say, hey, this can be any. And now it's kind of, we're specifying like, hey, now we can also take this, which has a value of a number, and now we can also specify that to be a string, and it's not going to throw any kind of errors because we told this variable, hey, this can be any type, so just treat it as type any. All right, so moving on now with the junior recap, we're going to cover two things that are used a ton in TypeScript. One is called make your own types. So instead of using primitive types, strings, numbers, etc., you can also generate your own types to tell the code what structure you want to be for objects and other variables. So first, let's cover types. So let's create a type called favorite band, and you can see here we have we're going to create a type where we can select various amounts of options for this type, and then we'll go ahead and create a variable called coolBand, and we'll set that equal to type favorite band. So now if I hover over this, you can see that this variable is now type favorite band, faveband. And if we go over faveband, this can be a multiple of strings, Weezer, Tool, Green Day, Dropkick Murphys. So if we go ahead and see this in action, we can go ahead and say Tool, no errors, everything looks good. If we change this to something such as Creed, now we're going to see a error and say type Creed is not assignable to type faveband. And again, because this is not in this OR operator for this type. So if we went ahead and said something like, OR Creed, now it's going to take care of that. So pretty basic type. So moving on now, we're going to go ahead and check out interfaces. And here we'll just use the keyword interface, and we'll make one path to senior JS dev. And we're going to put some properties in here such as language, which is going to be a string, drinks coffee, which will be a Boolean. And on here, we're going to use that to generate another object for, we'll say, let dev. So if you check this out, we have basic object, basic interface, language with string, drinks coffee Boolean. Down here we say, hey, we want dev to be type of path to senior JS dev, which is interface right up here. And everything looks good. We got language, which is a string, and we got drinks coffee, which is a Boolean, so it's all good. It's going to work. If we went ahead and change this to something such as yes, instead of true, it's going to throw an error. It's not assignable because it needs to be Boolean. But let's say we want to make these objects to be extendable even more, and we want to be able to add on different things and have custom things in different objects. That's not going to work in this case because now we throw on another property called cool with a value of true, and it's throwing an error because, hey, this is not on our interface. So to cover this, we can also go ahead and say, hey, we can also add a property on here with a key, but it's a string, and it can be type of any. Or you could also say this could be a Boolean or whatever. But you can now see the flexibility in how you can construct this to do what you want to do. Now we come down here, that error went away for cool, now it's a Boolean. If we said this had to be type of string, I'll see that's now going to throw an error down here. So interfaces are a really powerful way to encapsulate that code and put it in an object and put it in an interface and say this is the exact structure. These are the things that we need. You can also, we're going to cover this later on, but real quick, you can go ahead and do something like this where you say language can be optional. And do that, we're just going to put a question mark there. So if we went ahead and did something such as come down here and take language away, now we still have a valid object that has a type of path to senior JS dev because we made language optional. And if I took this away and said, hey, we need this language in there, now there's going to be an error saying, hey, you're missing a language. We need this property on there to be equal to a type of path to senior JS dev. All right, the last part of the junior recap, we're going to be covering arrays and functions. So starting off with arrays, it's going to look very similar to what a basic array declaration is. We'll create a variable like colors, which is going to be an array of colors. And right here, this is where we're stating, hey, this needs to be an array. We can let the string part of this out, But in this case, we're going to say, hey, we want an array of strings. So we make this right here. We got an array of colors, all consisting of strings. It's as easy as that. Now, if we go over colors, we can see it is an array of strings. If we try to put something in there, such as a number, that's going to break. But let's say if you want an array and you want to be able to have different types inside of there. What you can do is, as you'll see here, we can add in different types before the array declaration here. So this is going to be type of an array because of brackets, and we can say these can be strings or numbers. Now when we go ahead and look at colors, this won't throw an error. If we went ahead and took away the number, then this would break because it's saying, hey, this is a number type with some string types, and before we were just saying, hey, this can only be types of string. So pretty basic, but that's the syntax for declaring a type of an array and telling it what types can be inside that array. We'll go ahead and create a function called double me, which is going to take in a number. And again, here for parameters, you can see that's as easy as stating what type you want for this parameter. So we're saying take in an argument of num, and it's got to be a type of number. And then this one after here is going to be the return type. So this function is going to return, in this case, a number. And you can see return number times 2, which is all going to be number type. So we got number times 2 returns a number. So if we went ahead and called this, no problem. But if we change this to be something like, a string, again, that's going to break because argument of string is not assignable to parameter type number. All right, now the good part, we're moving into the senior dev level code. First thing we're going to cover here is forced required. And this will make a lot more sense here in a second. But if we take a look here, we're going back to making a general interface, and we're going to call this optional. And what this is going to do is it's going to take in a few things, a few numbers, x and y, and by putting this question mark in front of the, or after the variable, or after the key, it's going to say, hey, this is optional. So if we make a type and we don't have the y in there, it's going to be okay. But let's say we have this, but there might be instances where we want to force these to be not optional. In that case, we could do something like this. So if you go ahead and just make and use optional as is, we can see that, obviously we can generate an object and we can let out y and no problems. But if we want to say like, hey, we want a situation where we want both of these, a way of doing this would be we can create type need all, and we can put in a type that comes with TypeScript called required, and then put optional inside of there. Now this doesn't make total sense because the naming convention optional, obviously we're kind of like making that now required, so we would restructure this and probably make a different interface. But it's an easy way of seeing what required actually does on this interface. So now if we went back and made another object, now these would both be mandatory because now you see that there's no question mark there. And now we would actually need both of these properties inside our object. As you can see, this is going to lead to our next topic of mapping. So if we look at this real quick, we can see what's going on here for required. What it's doing is taking in a type, which is t, and it's going to pretty much iterate or map over this object. So p, which is property, in type of t, which is a type, and it's going to take away that question mark. And it's doing that for each property inside of that type. So it's pretty much iterating over the object and just removing all those question marks, which obviously is going to make it all mandatory. And keep this syntax in mind because we're going to see this in our next section, which we're going to take a look at right now, which is mapped types. Okay, so the last section we're going to cover here is called map types. And I like to think of this as almost like running a function over types to do something specific to that type and make it different. And keep the mindset of what we looked at before with required, how required kind of mapped through a type and kind of made everything required and took that optional property off of the type. So in this case, what we can do is we can do that, but we can do our own custom version of that. So if we take a look here, we're going to create our own type just called range, and we're going to use this in an interface here in a minute. But all this is going to do is create a type that allows numbers from 1 to 10. And we're going to use this to score food recipes. So here we're going to create an interface called recipe, and we can go ahead and create that using 3 properties. Number of ingredients, which is going to be a number, cook method is string, and score, which would be part of that range. So this could be anywhere from 1 to 10. And if we make a new version of that interface, and we're going to say let beef bourguignon be type recipe. And here we can see it's going to have 8 ingredients, simmer, score of 9. So pretty common. We've seen this before. We just made an interface, made a object, and using that, telling it to be this structure, using that interface. And we can go ahead and reach in and, just like any object in JavaScript, change the number of ingredients and so on. But now let's say we wanted to have more control over this. Yes, it is type recipe, but we want to go ahead and say we want to set this ingredient beef bourguignon, but we want to keep this set where they can't change any of these properties, because it's not going to change. It's always going to have the same number of ingredients. It's always going to be the same cook method. So what we can do is we can create a new type called read-only recipe, and you can name this obviously whatever you want. That's going to take in a type. And what we can do is we can use, just like we saw back in required, which is out of the box with TypeScript, we can create our own version of this using that property in key of type, which the type will pass in there later on, and property of that type. So it's going to map through all of this type and create read-only for all these. So to prove this, we can go ahead and say let read-only beef bourguignon be type of read-only recipe, and we're going to pass in recipe into that. So what's going on here is it's taking a recipe, which is not read-only, and we created a generic type around that called read-only recipe, which is going to take in anything we pass in and create read-onlys for all that. And now we have a read-only version of that recipe. So let's go ahead and see this in action. We can go ahead and paste in the same key value pairs, number of ingredients, cook method, score. And now when we go ahead and try to reach in and change one of these properties, we can now see TypeScript will throw an error, cannot assign number of ingredients, because it is a read-only property. So if we take a look at a different version of mapping over types, we can do a different one here. This is interesting because it's doing the complete opposite of what required did. So required mapped through all the key value pairs in the type, and it would take away anything that was optional. In this case, we're creating our own type called optional props, which is going to go through, taking another type, anything, and it's going to say if anything is not optional, make it optional. And then we can go ahead and pass in recipe again. And in this case, every key value pair will now be optional inside that recipe. Where you can see here when you hover over, part of recipe, now every one of these key value pairs is now optional, as you can see with the question marks. And there you go. That's pretty much the basics. I mean, obviously these get a lot more involved and a lot more complex, but these are the building blocks of some of TypeScript. And I think they're good use cases for TypeScript. And if you want to get your feet wet, or if you just want to kind of like get more involved in some of the more complexities around TypeScript, I think there's some of the good use cases for that. So thanks for tuning in, and let me know if you want to see more involved TypeScript videos, and we can really dive deep and get into more complexities around TypeScript.